Hello and a very good morning to all of you. My name is Muhammad Ilham bin Noor Farouk. My matrix number is 01DEE24F1024. And today I'm here to talk about the introduction of a bipolar junction transistor. A bipolar junction transistor is a three-terminal semiconductor device that plays a crucial role in modern electronics. It consists of two p-n junctions formed by sandwiching either p-type material between between two n-type material (npn) or n-type material between two p-type material (pnp). The three terminal of a BJT is known as emitter, base, and collector. The BJT operates by using a small current input at the base terminal to control much larger current flowing between the collector and the emitter. The characteristics makes BJT highly effective for amplification purpose. Additionally, BJT are widely used in switching application, making them essential in logic circuit, power regulation, and signal processing. Their ability to operate at high frequency and handle moderate power levels also contribute to their widespread use in analog and digital circuit. Now we'll be looking at the objective of this practical work, which is to sketch the symbol of transistor using multimeter ohm range to check and identify the transistor's electrode terminals, the NPN or PNP type of a bipolar transistor, the silicon or germanium type of a bipolar transistor to identify the terminals from its physical
Well, the
shape.
first thing here is
Let's move
the
on.
three terminal in a bipolar junction transistor.
Now I'll be
Base.
looking at
The
the
base is the center
BJT
terminal
terminal
of
and
the
its
BJT,
function. So the
and
base
typically is
terminal
very thin
controls
and light doped.
the
Doped
BJT
compared to
terminal
the
is
two other
responsible
region.
for
It serves
current
as the
flow
controller of a terminal
between
transistor. A
emitter and
small current
collector, as
entering
small current
or
entering
leaving
base
the
allow
base
larger
allow
current to flow
much larger current flow
from
between the
emitter to
collector and
collector.
emitter because
The
of its
collector
thin size.
terminal
The
is
base
where
allows
the
most
output
current
current
charges
flows
carriers
off the
from
transistor. It
emitter
collects
to pass
majority
through
of the current
into
passes
collector,
through the
enabling current
transistor when it's
amplifier.
in an
Second,
active
the
state.
collector. The
The
collector terminal
emitter
collects
terminal is
majority
the source of
charges
charges carried
injected
from
at
the
the emitter
emitter
through the
for
base.
NPN
It
and
moderately
holds
drop
of
as
4PNP. It injects
it's
its
moderately
carrier
doped and has a
into the base,
larger area
enabling
to
current
handle
to
heat
flow.
and
The
power
current flow illustration in
dissipation
NPN transistor, the
associated with the
current flow from
larger
emitter
current
to
it carries.
collector
The
when a
collector is
small current
usually
applied in
connected
the
to the
base.
higher
Diagram
voltage
shows
side
that
of the
uh,
circuit, and it plays a
NPN
key role in the
transistor with the arrow
transistor
of E to
ability to
B, which is
amplify current.
IB, the current in base,
Emitter is heavily
and
doped to increase
BC is the
efficiency in
current IC,
injecting charge carriers.
current in
Electron
collector.
in
In a
NPN holds in
PNP
PNP
transistor,
into
the
base region.
current
Its
flows
main
from
function to
collector to
supply
the
carries the
emitter, and a
flow
small
through
current
the
is
base
drawn
are
from the base.
collected by
Diagram shows
collector.
the
The
PNP
emitter is
transistor with the
usually
arrow
connected
indicating
through
C
the
to
ground
B,
or the
which is
lower
the
potential
IB,
side
the
of the
base
circuit.
current, and
It
B
is
to E,
responsible for
IE, the
initiating the
emitter
current flow
current.
in
Now,
transistor.
types of
In summary, the
BJTs.
base controls
NPN
transistor's
transistor.
operation
In the
with
NPN
small
transistor,
input current.
majority
The
carries
collector
are
receives
silicon,
an
and the
output
base are forward
amplifies the
biased.
current, and the
Electron flows
emitter
from a
inject
current
carries
emitter to the
into
base,
base,
allowing
starting
larger current to
transistor
flow
current flow.
from emitter to collector. PNP transistor. In a PNP transistor, majority carries holds when the base is a forward current. Holds from emitter to the base is allowing a larger current to flow from collector to emitter. Comparison of the current flow is in NPN it's EBC current flow from emitter to collector. In PNP it's CBE current flow from collector to emitter. In a biasing condition, NPN base must be higher potential than emitter forward bias, and the collector must be higher potential than the base for reverse bias. For PNP, it's vice versa. The base must be lower in potential than the emitter for forward bias, and the collector must be lower the potential from the base than the reverse bias. Identifying which one is the circuit symbol is shown. PNPN transistor. Testing method is using multimeter to test for PNP, measuring continuously between emitter and base and between base and collector for forward bias, and for PNP measure continuously between collector and base and between base and emitter for forward bias. BJT materials. BJT materials are mostly used as silicon and germanium. The most commonly used materials in BJT due to its favorable property is silicon, and germanium is historically significant but less common in modern application. Why is silicon more used? Thermal stability. Silicon can operate in higher temperature up to 450 C, making it suitable for a wider range of application. Lower leakage in current. Silicon BJT exhibit lower leakage current, which is crucial for power efficiency in battery and operate devices. High breakdown voltage. uh, high breakdown voltage. Silicon can withstand higher voltages and making it suitable for a higher power application and cost efficiency. Silicon is abundant and relatively inexpensive, making it a cost choice for mass.
As a conclusion or summary of the experiment provided a comprehensive understanding of the fundamental characteristics of bipolar junction transition (BGT). One of the key findings was the ability to accurately identify the three terminals, emitter, base, collector, and recognize their distinct function within the transistor. The emitter is responsible for injecting charges carrier. The base acts as a control gate with a very thin and light doped region. The collector gathers charge carries, allowing the transistor to amplify the current. The experiment also distinguished between two main types of BGT, NPN and PNP. It was observed that NPN transistors are more commonly used due to better electron mobility and superior switching characteristics compared to PNP transistor, which rely on a whole movement. The experiment is highlighted the direct in current flow voltage biasing required for each type, emphasizing the importance of correct orientation and connection in circuit application. Additionally, the experiment investigated the semiconductor material used in BJTs, primary silicon and germanium. It was noted that silicon is also preferred material in modern transistors due to abundance, cost effectiveness, thermal stability, the higher voltage tolerance. Germanium is less common today, offers low voltage drop, was historically significant in early transistors development. Now, the importance of understanding BJT terminals, types, and material in circuit. A true understanding of BJT structure and behavior is critical for effective electrical circuit design. Recognizing the function of each terminal ensure that the transistor is correctly incorporated into circuit, which is essential for achieving the desired amplification or switching performance. Misidentifying or improperly connecting the terminal can lead circuit malfunction or damage. Differentiating between NPN and PNP transistor allow designers to select the appropriate based on the circuit logic and power requirement. For example, NPN transistors are often favored in low side switching while PNP type are used in high side configuration. Understanding the direction of current flow are necessary. Biasing condition for each type helps to ensure proper operation and efficient of the circuit. Furthermore, knowledge of material used in BJT construction plays a significant role in component selection. Different materials offering varying electrical and thermal properties that can be affect the transistor speed, gain, and reliability. For instance, choosing silicon based on transistor for high temperature application enhance circuit durability, while selecting a low voltage of germanium transistor may benefit a sensitive analog signal processor. In summary, mastering the fundamental of BGTs, including their terminal, type of material, provide engineers and technicians with the tools needed to design reliability and high-performance electrical circuit. This foundation knowledge supports both everything from simpler amplifiers packages to complex digital switching system, making it indispensable in both education and professional electronic engineering contexts. Thank you, and that's all from me.